Welcome to qnawire.
We're given the average value of r, which is just the r with the brackets outside of it, and we're told it's equal to 3a0 over 2. The average value of the squared distance between the electron, r squared, is given by this integral. So we'll scroll down and I'll show you the integral that we're given. So this r squared value is equal to the integral of 0 to infinity of the probability density times r squared dr. So the question is, well, what's the probability density? And we can use this to find the uncertainty in the radial position of the ground state of the electron, because we already have the average r value. Now we just need the root mean squared value. So we're going to use the wave equation, because the probability density is equal to the area times the wave equation squared. The wave equation is equal to 1 over the square root of pi a naught cubed e to the minus r over a naught. So we just need to square that term. So this is 1 over pi a naught cubed e to the minus 2r over a naught. Then you multiply that squared term by the area, which is 4 pi r squared, and you get 4r squared over a naught to the third e to the minus 2r over a naught. So this is our probability density that we're going to use in this equation to solve for the root mean squared value. So go ahead and doing that, we find that this is equal to the integral of 0 to infinity, because that integral over all space, of 4 squared over a naught minus r over times r squared. So I just looked up an integration rule, because you can also write this as integral of 0 to infinity of 4r to the fourth, right? Because it's r squared times r dr. There. I just plug this into an integration table and solve the integral that way. You can spend all day solving the integral, but this is a physics class, so let's go ahead and actually get to the integral provides. So this is negative 1/8 a naught to the fourth pulled out front, bracket. We have 16 r divided by a naught to the fourth plus 2 r to the third over a naught to the third plus 48 r squared over a naught squared plus 24. Each one of these values is multiplied by e to the minus 2r over a naught. So we multiply each of these by e to the minus 2r over a naught. And this is carried out from infinity. This entire thing grow to infinity. Well, e to the minus infinity is 0. E to the 0, 1. E to the 0. So we can use that to, so if you plug in infinity, every value is going to be equal to 0, because each value is multiplied by e to the minus infinity. And if you plug in 0, all the values go to 0 except for the value 24, because they're all multiplied by some value of r, whether that be r to the fourth, to the third, or squared. So you plug in r equals 0, and no matter what you multiply it by, anything times 0 is 0. So what we end up with is this coming out to equal negative 1/8 times a naught fourth times negative 24. Negative 24, because this comes in plug r equals 0, and it's infinity minus 0. So the infinity value minus the 0 value, so that 24 is a negative 24. Or another, this equals 3 times a naught to the. So now I have that value. So we can go ahead and solve for the r is equal to square root of the average r squared minus the value squared. So this is equal to the square root of 3a naught to the 4th minus 3a naught over 2 squared, which is 9 over 5 squared. I'm going to pull an a naught out front. So a naught squared square rooted is just a naught. So I'm pulling that out front. And this is multiplied by the square root of 3a naught squared. Nice. So 3a squared minus 9/4 is the question. So we can go ahead and box that. Well, a naught times the square root of 3a naught squared minus 9/4.